Now, if they said if two, the last one, he said if two particular books must occupy the ends, that means they are not together. That's C aspect of it. If if two particular books must occupy the end, that means that finished something. Remember what I did for L is to say if they are not together, they said two. That means this C, this B, this A. So if two must what? Must be at both ends. So the two can be arranged and meet themselves in what? In two ways. So the first egg can occupy how many positions? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 6 positions. The second one can occupy 5 positions. Now, because they are what? Hello, Shay.
Because they are was
Hello.
hello, I'm here, I'm here.
Differentiable objects. We divide it by 2. That's where the 2 is coming from. So these two can cancel together unless it was 38. Are we together?
Yes.
So that's the solution to that. Which other one did I give you? If it's not the
That
same,
was all.
I gave you 2 now. I gave you 3.
Oh, you gave me 6.76.
Okay, these on combination. I don't think I've taught you that. 6.7. That's on combination. So let's go back. We'll come back to that question. I've not taught you combination. So we thought that the 6.9. Let's go back to 6.9, page 151.
All right, so I'm there.
A and B play third game of players of which 6 are won by A, 4 are won by B. Can I rub up this?
Yes.
6 are won by A, 4 are won by B. Are we together?
Yes.
And in a what? In a draw. So the total sample is what? Total sample is 12. I believe you can see the board. Total sample is 12. 6 1 by A, 4 1 by B, and 2 N in a draw. Let's call the one that ends in draw C. Two. This one is draw. Hmm.
Yes.
Hmm. So they said find the probability that what? A wins all 3 games. Find the probability that what? How many games? They agree to play a match of what? Consisting of 3 games. So find the probability that A wins all the 3 games. That means A won the first game, A won the second game, and A won the what? The last game. Are we together?
Yes.
A won. is given by what probability A won the first game and A won the second game and A won the third game. Eh? So in probability, this is like A times probability of A times probability of what? A. And this one means and. And the probability I have to multiply. So what probability of A here is 6. That is 6 over what? What's the total? 12 times 6 over 12 times 6 over 12. Are we together? Is that one clear? Then you do the mathematics. That's like
Yes.
half times half. That's what 1 over. So on the first, is that one clear? Can you see my marker?
Yes, I can see your marker.
Next one is 2 games end in a draw. 2 games end in a draw. How can you interpret that? Out of 3 matches, 2 end in a draw. How do you interpret that?
You said if what?
Look at the question. They said they agreed to play a match consisting of 3 games. What probability of question 2 that 2 end in a draw? Are we not on the same page?
Yes.
How do you interpret it? Can I rub up this?
Wait, hold on.
2 ends in a draw.
The probability is 5 over 72.
How do you interpret it? I didn't say you are just giving me the answer like that. Interpret it. Don't just give me the answer.
Okay. Probability of the first and second.
The answer there.
You
Interpret.
said
Don't look at the solution there. Interpret it on your own.
you have to do all the combinations of the. There are 3. I think there are 3 possibilities that 2 games went in a draw.
There are
Out of the 3, I think the possibility that 2 of the games went in a draw, right? There are 3 combinations you can do here. That's first and second game, second and third game, first and third game. So
so
you combine all of them.
first and second end in draw. Abi. What happened to the third?
Yeah.
What happened to the third one? What are you going to say concerning the third one? If there are 3 combinations, it means I must have maybe it's C that ends in draw. That means C1, C2, C3. I must have 3 possibilities. So if the first and second end in draw, what happened to the third?
The third one will not end in a draw. So you do 1 minus the possibility that 1 ends in a draw.
That means the third one does not end in a draw. So that's the opposite of the one that ends in a draw, right?
Yes.
Are you okay with this one?
Yes.
Probability of C means probability of C1 and C2 ends in draw. And as the probability, let me be using C. And C prime. C prime means the one that doesn't end in draw. Are you with me?
Yes.
But let me be changing it. Let me put C1, C2, and put C prime as the. So if I'm taking C1 and C2, another possibility is C2 and C1 ending in draw, and C prime doesn't end in draw. I've transposed it. While the last case you can have is what? C prime intersection C1 intersection C2. C prime intersection C1 intersection C2 doesn't end in draw. You can use tree diagram to do this. You can use tree diagram. You know what I mean by tree diagram?
Yes.
Tree diagram, you will get this list I am talking about. So if probability of C1 and the probability of C here is 2 over the total, which is 12, right? So how do I interpret this? The first one, C1, here is what? 2 over 12 times 2 over 12 times, what's the opposite of C prime? One that doesn't end in draw. What's the opposite? That would be what? 10 over 12. Do you agree with that?
Yes.
And so all this one now, you now multiply it in how many ways? Times 3. Okay? It will be the same thing. 1, 2, 3, occurring how many times? 3 times. Are we together?
Yes.
Or you can say plus, and the same plus this times 2 over plus again. So they are just the same. Eh? So if you do this, you should get 5 over 72. Any question on that?
No.
Why the last case? The C aspect of the third, find probability of A and B win alternatively. A and B win alternatively. Can we do that together? A and B win. Are you okay with this one? Can I rub it off?
Yes.
They are still O levels. A and B wins alternatively. The only case I can have here is to say I have what? A, B, C. If A doesn't win, B will win alternatively. Plus, if if uh if C fails, then I can have A intersect B alternatively. Are you with me? They must be together, but I can't have this case. ACB is not alternatively. They should what? A and B should go together. That's what they meant by alternatively. Are we together?
Correct. Yes. Correct.
Must be together. So for you to interpret the probability A wins is what? 2 over 12. Probability B wins is what?
Probability B wins is let me continue.
2 over 12, right? Probability
Yes.
B is 2 over, B is 6 over. You are not following me.
No, I'm looking at the question. What 12 times 2 over 2.
Probability of C is this. Probability of A is what? Probability of B is what?
4 over 12.
B. 40. 40. So you are saying 6 over 12 times 4 over 12, and if you do the math, then you get what? 5 over 30.
Let me show you. 5 over something. 5 over 36. Yes, you get 5 over 36.
Now, the third, find probability that what? The last question is find probability that what? B wins at least one game. In a match of 3, B wins at least one game. It means the interpretation of that is that what? B wins the first game, B wins the second game, and B wins the third game. That's the way you have to do that interpretation. But when you go through that route, you'll be having a lot of things to calculate. So the best way you can do is to say 1 minus B wins no game. Are we together?
Correct.
So if you go through the route of B wins the first game, B wins one game, B wins 2 games, B wins 3 games, and you add them together is a long way of calculating. You can do that. But if the other way around is to say 1 minus B wins no game. Now, probability that B wins no game is this. Just leave it right.
It is going.
B wins the game, right?
Mm-hmm.
1 minus probability wins the game. That's what? 8/12, isn't it?
Yes.
Let's say it's a 4-year what? 2. 4-year what? 3. 2/3, right?
Yes.
Probability of B wins at least 1 game is given by 1 minus probability B wins no game. The probability B wins the first game, B wins the second game, and probability B wins what?
Third game.
So that's 1 minus what? No game, no game, no game. 2 times 2/3. This is no game. Do you understand what is on the board?
Yes.
No game is 19/10. I'll be calm now. You'll be giving me the answers. I won't be that fast taking. I want you to respond. Any question on what is on the board? No, right?
No question. No.
We move to probability distribution. Probability distribution. Now, probability distribution, they may tell you to generate a distribution for a set of what? For a set of events. So, can I rub up this?
Yes, you can rub off this.
Now, look at 6.10. Find probability of boys and girls in families with 3 children, assuming equal probabilities for boys and girls. Find the probability of boys and girls in families with what? How many children? 3. Sample 3. Probability of boys, equal probability 1/2. Probability of girls, equal probability is what? 1/2, isn't it?
Yes, that's correct. That's correct. Correct.
1/2. It's either a boy or a girl. So we are not considering biology, hermaphrodite, and all that. We are not considering that. So in a family of 3, find probability of what? Want to generate a distribution table for this. They say find the probability of boys and girls. Assuming equal probability. So the first one is to take probability of 3 boys. Look at it in your notes. Probability of 3 boys. Yeah, first one is a boy, second one is a boy.
It's 1/8. 1/8.
Now, why am I having BBB in 3 places? Why can't I have B and B? Why am I having? I need an explanation concerning that. Why am I having BBB? Why can't I have B in 4 places? Why can't I have B in 2 places? Why is it B in 3 places? What warranted B in 3 places? Because they said
3 boys. They said 3 boys now.
because they said in the family of 3.
Yes, they said 3 in the family of 3.
This family of 4, it will be 4 boys. Now, so that's 1/8. Then you try for girls. Girls is the same thing, 1/8, right?
Yes.
They said if we have the other option you may have in that probability, so have 2 boys and 1 girl. So you have 2 girls and 1 boy, isn't it? If you have
Yes.
2 boys and 1 girl, and the other option you can have is what? A girl and 2 boys. Those are the options you can have. So when you do that, you have 1/8 for 1/8 for 1/8. That will give you what? 3/8. Are you with me?
Yes.
And the last case is to have 2 girls and 1 boy, girl, boy, girl, and you have boy, girl, girl. So when you do the same thing, you get 1/8. So the distribution goes this way. Look at page 153. Have you seen 153? Have you
Yeah,
seen?
153. Well,
If we have no boy, it will be what? 1/8. If we have one of the over 8, we have 2/3/8, and we have 3.
1/8.
There are questions pertaining to that. Are we together?
Yes, we're together.
Now, another question I want to solve is question on expectation. I think I've do the expectation before. Expectation of X, the first probability of X. Abi,
Yes.
expectation of X is the mean. Are we together?
Yes.
This particular one. Can you see this side? This side of it. Can you see? In front of it, can you? Shall I tell you?
Yes.
What did I write there?
X.
Right?
Yes, X bar.
I thought the reflection would not allow it. So this one, 1-3. If a man purchases a raffle ticket, he can win a first prize of $5,000 or a second prize of $2,000. The probability of what? The probabilities of with probabilities of
Wait, let me
no, this one, 1-3.
6113. You can win the 0.01 and 0.0, sorry, 0.001 and 0.003.
Be a fair price to pay for the what? What should be that an expectation? Question and expectation. To multiply the X by the probability. The X here is 5,000 and the probabilities are what? 0.01 and 0.0. So you multiply
It
5,000.
comes out. I want to quickly use the restroom. I want to use the restroom. I'll be back, sir.
Did you want to go restroom? Àti tó pé ní ìfẹ́ àwọn àwa tí lọ́gbẹ́ sọ pé wọ́n lọ pé tọ́ba ní fún ọ̀tọ̀ browse wọ́n lè chẹ́kì wọ́n chẹ́kì ọmọ introduce ìfẹ́kọ̀ lọ tẹ́ sínú àgọ́ wọ́n máa pọ̀ àwọn olùdó àpapọ̀ lọ́mọ náà pé lókè wọ́n ní pé kí n lọ́kàn ọ̀tọ̀ lọ́kàn náà ọkọ̀ wọn náà ló lè fún wọn. Pé kí ọkàn wọn tó àti ṣe fellowship pẹ̀lú wọn ní Sunday tó bíbẹ̀ ẹ̀ ṣe ràn kó bá àwọn ṣàgbéṣọ̀ pé àwọn fẹ́ jẹ́ báàrin ṣé báàrin àti báàrin di ìyàwó àwọn sí ìmàjẹ́ tó bá àwọn àtẹ̀lé access ọjọ́ tó ní ẹ̀rọ wọn lè mú picture wọn dání nǹkan ìpèrè ìrìn náà pé rádà nǹkan lọ sí ọ̀dọ̀ èmi sọ pé àpá àgùntàn fún wọn ni idol tóun náà sìn olórí ẹ̀rì fún àwọn lọ síbẹ̀. ìnáwó ní pé wà àwọn bá wọn ní kàn táwọn làwọn tètè ṣàn fún àwọn ọ̀dà tó ń gbé ló ń tètè tàn pé lóòótọ́ ni wọ́n ní ipa pé fáìn wà bí wọ́n kọ́lé pé ìgbà tí nǹkan ìṣẹ̀lẹ̀ ní wọ́n ṣẹ̀ṣẹ̀ rántí pé ìfáwà pé àwọn yẹn fọwọ́ sí pé kọ́ lọ ṣe ìtẹ̀ kọ́ lọ bọ́ wọ́n á ní pé kọ́ lọ bọ́ ẹ̀ tẹ̀rọ pé nǹkan yẹn èrò pé ẹ máa rí pé kò ń ṣe nǹkan yẹn lẹ́ máa bọ́ lókè yìí ẹ máa rí pé kò ń ṣe tẹ bá jẹ̀ sọ pé ẹ bọ́ nǹkan míì ní fi máa fi mú ó lè má jẹ́ àwọn ọmọ ó lè má jẹ́ ìmọ̀ nípa ìṣòwò fún yàn nípa lọ́fẹ̀ẹ́ tó wá fi nǹkan gbà kan lọ́wọ́ èèyàn wọ́n ní pé ìkọ́ tó yẹ káàpá yẹn ṣe ni tó yẹ kọ́ tẹ̀lé ń lọ síbẹ̀ kọ́ sun ifá yẹn kọ́ dẹ̀ separate ní from ọ̀nà yóò rẹ̀ ẹ sọ pé èṣù yẹn ló yìn bọ̀ ni. nǹkan tẹ́lẹ̀ mi ti ṣe ìlú pa fáwọn fámìlì rẹ̀ kò ṣe òun lóyìn wọn kò pa á ẹ̀yẹ́ ìgbà ó. bẹ́ẹ̀ wo kan tí dáàdi ṣe ìjọba kan kan dáàdi fẹ́ ká lọ bàbá wa bẹ̀rẹ̀
Lọ́mì kan ọ̀fẹ́, lọ́mì kan ọ̀fẹ́. Irú nǹkan tó lọ sọ́dọ̀ fásitì tó wà náà, fásitì gan-an kò dẹrùn. Wọ́n mi ń ṣètò aláàdì ìṣètò.
ṣé ifá ẹ̀wọ̀n ọ̀gbọ́mọ ni ló ṣe wá jẹ́ pé àwọn ọmọ ló wá pàdé ìgbà tó tó stéèjì tó yẹ kó wá
Devil, this time to strike.
ìgbà tó yẹ kó bẹ́ẹ̀ pàdé tó
Ó lè
yẹ
má
kó
dúró.
tẹ̀ tó jẹ́.
Ó lè má dúró. Ọ̀gbẹ́yàn bá ti gbogbo.
Nǹkan tó ń sọ ní káwọn bá tẹ̀ lọ síbẹ̀ kára ń sọ pé ó ti di tẹ̀ ń lọ ní ẹ̀rọ ìwé ìgbìmọ̀.
Tó sọ tó bá yẹ pé natural sickness ni tó wá. Tí ó sọ pé ẹ̀jẹ̀ cancer lọ sọ. Tó jẹ́ cancer, àti rí kéèsì cancer tó wà.
Ọ̀wọ̀ mi ní pé tó bá dé bẹ̀ wọ́n á rí kéèsì ju tí wọ́n lọ. Nínú kéèsì ń yí kéré. Kéèsì tí ń yìn ó yí kéré. Nínú pé àwọn ẹlòmíì tó ń fi oxygen para ní ìfẹ́ wọn lẹ́nu. Kéèsì ẹlòmíì kò lè rìn rárá. Wọ́n gbé wá chọ́ọ̀chì dẹ̀ ni wọ́n gbé wá. Kéèsì tí ń yí kéré. Nígbà ìgbà tẹ́lẹ̀ ní wọ́n mo ní stroke lẹ́yìn. Rí bẹ́ẹ̀ ni mo lọ ń gbé
àwọn ọmọ.
wọ́n ní pé wọ́n ní stroke ní pé yes ó ṣe mí. Wọ́n náà fi tàn jù lọ ní pé gbogbo ẹ̀ lọ́rọ̀. Ó ti padà nípa ẹ lọ síbẹ̀.
Okay, so I'm back. I'm back.
Pé àwọn ọkùnrin jẹ́ Muslim. Wọ́n gbé bàbá àwọn àtọ̀hún kọ́ lọ sí fẹ́ lójú ọ̀tẹ̀ ògbó èrè. Can we move on?
Yes.
This expectation now, in statistics, we call it the mean. Can you see the board?
Yes.
Call it the mean. Now, we are told to calculate what should be a fair price to pay for the ticket. That's they are expecting you to calculate the price to pay for the ticket. That's expectation. So what I'm going to do is you multiply the 5,000 times the probability. Now 5,000 times 0.01 plus the other case is what 2,000 times what? We are following 2,000 times 3.
Yes.
0.00.
You said 2,000.
Isn't it? If you do that, you get $11.
Yes, 5 plus 6 is $11.
So the same way with in a given business, a lady can make a profit of $300 with probability of 0.6 or take a loss of $100 with probability of 0. Determine expectation. So that would be what 300 times 0.6.